Good day, Dr. Rashida and fellow friends. Today, me and my groupmates are going to present our operating systems project, which the topic is fixed and dynamic memory management, next fit and worst fit. My name is Ng Yen Tong and my groupmates are Thi Jun Ho and Teo Yi Xian. In this project, we distribute the tasks equally no matter our project report, our source code, and our presentation video in order to ensure that our project is carrying on smoothly and effectively. First of all, let me introduce our project. The purpose of this project is to enhance the comprehension of the algorithm for the group members, as well as those who view the project. For this project, we need to propose a real-world application as a case study and choose a suitable dataset to simulate or to visualize the assigned operating system concepts or algorithm. In this case, we are required to prepare either an animation, visualization, or simulation through programming or algorithms in the operating system covered throughout the course. The topic we have decided for this project is fixed and dynamic memory management, next fit and worst fit. In the operating system, fixed and dynamic memory management belongs to contiguous memory allocation. In this case, placement algorithms such as next fit and worst fit are used for selecting among 3 blocks of main memory. Next fit is allocating the first hole that is big enough, and the search starts as the last hole allocated. In the meanwhile, the worst fit is allocating the largest hole and it must also search the entire list. Worst fit will produce the largest leftover hole. Next, it comes to the problem statements of this project. Under the circumstances, the traditional service way, that is allocating the canned potato chips manually into boxes, causes several problems for the factory and their customers. First, the efficiency of allocation job is slow. Second, it is wasting time and human resources. Third, it has a high error rate and will cause inconvenience to the customers. The selected operating system concept for our group is fixed and dynamic memory management, that is next fit and worst fit. Operating systems should keep a record of each memory address, recognizing which are available and which are occupied for both fixed and dynamic memory allocation schemes. The unused partitions must therefore be allocated as new processes are added to the system. There are 4 ways to allocate those unused partitions, but in our project, we will only cover 2 ways, which are next fit memory allocation and worst fit memory allocation. Worst fit memory allocation method navigates all memory, always looking for the biggest partition and then placing the process within the hole or partition. It is a time-consuming process because it must navigate the whole memory to find the biggest partition. Next fit memory allocation method refers to a modified version of first fit memory allocation. It starts just like the first fit to find and fits the process to the first found available partition, but when called again, it continues searching from wherever it left off, rather than from the start. A roving pointer is used in this method. The pointer navigates the memory series in search of the next bit. It aims to help prevent using memory from the initial stages of the available blockchain. The project will have few stages. First, we will brainstorm a real-world situation or application that is related to our topic and decide whether to present it using coding or animation. In this project, we use to visualize our projects using the coding method. After that, we will complete the proposal and let the lecturer examine it. If the lecturer approves, we will start to design and implement our project in code using C++ language. If not, we will improve our proposal again. After the coding is done, we will complete the report and the demo video of the project. Lastly, we will submit our project report and demo video to the lecturer. In addition, the hardware and software requirements for our project will be laptops, programming tools such as Dev C++, Microsoft PowerPoint, Microsoft Word, and WhatsApp for discussion. As mentioned above, the method used in demonstrating the next fit and worst fit algorithm is by coding. By using a coding method, we will be creating a C++ menu that allows the user to interact inside. This figure shows the expected flowchart of what will be happening in our coding program. At the start of the menu, there will be 2 options to be chosen. There are next fit algorithm and worst fit algorithm. These two options represent the corresponding algorithm. After the end of each of the algorithms, the system will ask to restart the program. If the user chooses yes, then the system will restart. If not, the system will quit. Next, I will pass to my group member, Teo Isian, to explain about our source code.
I'm Teo Isian, and I'm going to explain the source code of the project. So the programming language we're using is C++. That's why I'm going to start with the main function. So in the main function, the first thing the system will do is to display these two lines. So the title is going to be the allocation of canned potato chips in Peanut Factory. And the algorithm is next fit and roast fit. So the system will run into this function, which is menu. In this menu function, the system will ask the user to input either one or two, which is the next fit or roast fit respectively. So after the user input either one or two, it will be stored into this algo, and this algo will be returned as an integer value into this algorithm. So when the algorithm is equal to 1, it will fall into the next fit. Yeah, and over here the can is often like representing as the block, and chip is representing as process, and both this block and process is set into 5. And here we're going to declare all the variable that will be used in the array. And the can size is the block, which it store 5 value, while the chip amount is the process, and it is also store 5 value. Then the system is going to ask for the size of 5 chips can, which is the size of 5 block, in the format of like 100 spacebar, 200 spacebar, and so on. And this string is stored in the can record by using getLine, and we get all the pieces by using the string, and then we going to need the while loop, and this x is going to be the pieces, the value of pieces, and it is reading the value before the spacebar. Like we have the 100 spacebar, 200 spacebar, right? So the x is going to be 100 because it's reading the value before the spacebar. So this x is going to store into can size, the can record, and the can record is now 100, but it is string, so we need to change to the integer. So the value is now having the value of 100, and it is stored into the can size, the first value of can size, because the num is declared as integer. So now the C1 is having the value of 100. Then the process is repeated with the C2, C3, C4, and C5. Yeah, after that, the system will go to ask the user to input 5 amount of process, and the process is just similar as the block one, and it will be stored into this A1 until A5. The size of the can size and the size of the chip amount is stored in the M and N respectively, and this value is going to be needed in the next fit algorithm function. So it's stored into the next fit. It's becoming the argument in the next fit function. So in the next fit function, we start off by declaring the temporary array named allocation chips, and we declare the j as 0, and then we set all the value of allocation into -1 using this set, and then we're going to start finding the suitable block. So we're going to take the first process first to do it. So we declare this thing, like we declare the I into 0, and we're going to take the 0 to start to find their suitable block. Okay, so then as we declare the j into 0, so we will start to find the first block first. Like if the first block is larger than the first process, then it will be storing the process into the block by using this code. So over here, the allocation, the first value of allocation is storing the value of j, because the first process is stored into the first block. So we declare this thing. It's like the allocation is representing the process, and the first process is stored into which block in this case, the first process is stored into the first block. And after restoring the first process into the first block, we're going to reduce the size of the first block. So we needed this code. Yeah, like we minus the first block by the first process. So it will be the remaining space in the first block. Yeah, if this happens, we break the if loop, showing that the first process is already found their block, and we will be continue with the second process. But if the first process is not fitting in the first block, then the block will be incremented by 1, which means that the first process is now checking for the second block to see if is able to fit in to the block, and the process is continue by +1 by checking the third block, fourth block, and fifth block. And then if the block is unable to find it, it will be run into here, which means that the process is break and is not allocated. Then after running through this, which means that the first process is done, and we will continue with the second process until the fifth process. Yeah, after we assigning all the process into the block, either is allocated or not, we're going to print the value. So this is the process of displaying either the process is allocated or not over here, and I'm not really explaining it because it just display. Okay, so this is how the next fit algorithm works. And then we're going to running to the check back. It will be returned yeah. So this is all about the next fit. Okay, so on the other hand, if the user type in 2, then it will run into the worst fit. And actually, this process is just similar. Yeah, getting the value of the block and also the process, and run the worst fit function, which is also the worst fit algorithm. And the only difference in the worst fit is check through all the block and find the largest block, so that to let the first process to fit in the largest block, and continue the second process, third process, and so on. Yeah, and after that, it will be storing display the value over here. So after done either of the algorithm, yeah, it will be run into here to ask that if the user want to continue the program. If the user want to continue, they'll click 1, so the process, the system will be restart and start over to choose over and over again. Now if the user want to quit the program, they will choose 2, which means that the program will be terminating and by. Yeah, okay, so I think that's all about the explanation of source code on our project. Thank you.
Next, I will pass to my group member, T. Jun Hong, to demonstrate our program.
Okay, so I'm T. Jun Hong, and I will be presenting the output of the program. And for this project, we have constructed a C++ program to apply the algorithm next fit algorithm and the worst fit algorithm. And we have recreated the real-life example of the allocation of canned potato chips in Kellogg factory in our program. And for our program, we have a title followed by a menu, which have 2 options, which is to implement the next fit algorithm or worst fit algorithm of the potato chips allocation process. So to allocate chips using next fit algorithm method, the user can input 1 into the output display, and then press enter. After that, the user will be required to enter the size of the 5 chips can. And in this case, the example would be 20, 40, 70, 20, and 35. After that, the system will request the user to enter the amount of chips of the next 5 allocation processes. So for this example, it will be 10, 25, 15, 40, and 35. So after the user has input all the information above, the user will perform the next fit algorithm, and the result of the 5 allocation process will be displayed. And from the result, we can see that the first process that has 10 chips will be allocated in the first can. The second and the third process of the chips will be allocated in the second can. And the fourth process will be allocated in the third can. And the last chip will be allocated in the fifth chips can. And after that, the allocation will end. And we can choose to restart the program or not in this case. And I will choose yes. I'll choose yes to restart the program and to present the second algorithm, which is the worst fit algorithm. For the worst fit algorithm, user can input number 2 to allow the system to use this allocation method. So same as the next fit algorithm, users will be required to enter the size of the 5 chips can. So in this case, the example would be 10, 70, 30, 50, and 25. So after that, the system will also request the user to enter the amount of chips of the next 4 allocation processes. So for this example, it will be 20, 15, 40, and 10. So after the user has input all the information above, the system will perform the worst fit algorithm, and the result of the 4 allocation process will be displayed. So the first and second set of the chips will be allocated in the second chips can, as it has the largest space. And the third set will be allocated into the fourth can, which have 50 chips space, and which is the largest, since the second chips can space is now left 35 after the first and second processes. So the last set of chips will be allocated again in the second chips can, as now it has the largest space, which is 35. So to terminate the program, user just has to input number 2 when the system asks the user whether or not to restart the program. So here we press number 2 and the program will be terminated, and this is all for the output of our project, and I will pass the next presentation to my teammate. Thank you.
The challenge faced throughout the project is about finding a suitable topic that fits the next fit and worst fit algorithm. This is because these 2 algorithms can be applied in limited applications. For example, it is not suitable to be implemented in moving seats, as it is impossible to have 2 strangers sit together in one seat. The benefits of implementing the next fit algorithm is that this algorithm is a straight and fast algorithm. It can find and fit the process into the suitable block very fast compared to the first fit algorithm. Besides, the benefits of implementing the worst fit algorithm is that there will be a large internal fragmentation on a block because the smallest process is being faced in the largest block. This causes the internal fragmentation of a block to be big enough to store other processes. After doing this project, we gain some of the precious experience. Firstly, we are able to communicate between one and another as a team and finish this project smoothly. Besides, we are also gain some knowledge regarding the next fit and worst fit algorithm. Before ending this section, we would like to thank our lecturer, Ms. Rashida Binti Kadir, for not only giving the chance to strengthen our knowledge about these 2 algorithms, but also always motivating us to keep on doing the task until success. One of the shortcomings of this project is that we are only performing the coding part instead of animation and demonstration. Here comes to the end of our presentation. Thank you very much for listening and have a good day.